540. That is the number of REM a human body would absorb in a single day standing on the surface of Europa, Jupiter's famous ocean moon, the one NASA spent billions of dollars to reach. 540 REM in one day. A dose of around 600 is enough to kill roughly half the people who receive it. So one afternoon on Europa, the moon everyone wants to visit, the moon we describe as the most likely place in the solar system to find alien life. One afternoon there, unshielded, would leave you dying. There is another moon orbiting the same planet. It is almost exactly the same size as the planet Mercury. It has water ice across its entire surface. It very likely hides an ocean of its own. And it sits far enough from Jupiter that the radiation falling on it is a tiny fraction of what hammers Europa. You could stand on it. You could build on it. And in 2003, a NASA study did the math, looked across the entire Jupiter system and picked it, not Europa, as the one place a human crew should actually go. Almost nobody made a video about that moon. We are about to fix that. This is Callisto, the moon we overlooked for 400 years, and the reasons we dismissed it turn out to be exactly the reasons it might matter most. Tonight we're going to do something the documentaries about Jupiter almost never do. We're going to take the boring moon seriously. We're going to walk through what it is, why we ignored it, what a spacecraft found hidden inside it, and why a team of NASA engineers, given a blank page and the whole solar system to choose from, drew a circle around this exact world. By the end, the word boring is going to feel like the strangest thing anyone ever said about it. Start with the night it was found. In January of 1610, Galileo Galilei pointed a crude telescope at Jupiter and saw 4 points of light that did not behave like stars. Night after night they shifted position, swinging from one side of the planet to the other. They were moons, 4 of them, and they were the first objects ever discovered orbiting a world that was not Earth. We call them the Galilean moons. From the inside out, Io, Europa, Ganymede, and Callisto. 4 worlds, each one a place in its own right. Io is slightly larger than our moon, Europa is slightly smaller, Ganymede is bigger than the planet Mercury, and Callisto, the 4th, is very nearly Mercury's twin in size, 4,821 kilometers across, against Mercury's 4,879. If Callisto orbited the Sun on its own instead of orbiting Jupiter, we would call it a planet, and we would have sent probes to it decades ago. That discovery, those 4 moving points of light, was not a small thing. It was one of the most dangerous ideas in history, for Galileo had just shown with his own eyes that not everything in the heavens circled the Earth. Here were 4 objects circling something else entirely. The old picture of the cosmos, with our world fixed at the centre of creation, had a crack running through it, and 4 little moons had put it there. Io became famous for being on fire, the most volcanically active body in the solar system. Europa became famous for its cracked icy shell and the ocean beneath it. Ganymede became famous for being the largest moon in the solar system, bigger than Mercury, with its own magnetic field. And Callisto, the outermost of the 4, became famous for nothing at all. For 4 centuries it was the moon you mentioned last, in the same breath as the other 3 before moving on. The boring one, the grey one, the one covered in craters and apparently nothing else. When NASA, ESA, and a generation of documentary makers went looking for drama in the Jupiter system, Callisto was the moon they walked straight past. And consider the scale of the thing we shrugged at. 4,821 kilometers across is not a pebble. Lay Callisto down on a map of Earth, and it would stretch from the west coast of the United States most of the way to the east. A single ball of rock and ice wider than the contiguous United States is from end to end. It is larger than the dwarf planet Pluto. It is more than 1/3 the width of Earth itself. This is not a minor satellite tagging along behind a planet. It is a world. We just happen to file it under moon and stop thinking about it. Here is the strange part. By almost every measure that matters for a human being, Callisto is the friendliest of the 4. It is roughly the size of Mercury. It has water. It has an ancient, stable, predictable surface. And it is bathed in the lowest radiation of any of the Galilean moons. We spent 400 years calling it dull. We may have been calling it safe. And consider how little attention that judgment was based on. In 4 centuries, no spacecraft has ever orbited Callisto. No lander has ever touched it. Voyager 1 and Voyager 2 swept past in 1979 and sent back the first real photographs. Distant, grainy, just enough to confirm the craters and not much more. The Galileo orbiter in the late 90s gave us our best look, a series of flybys at varying distances, and that essentially is the whole file. Everything humanity knows about a world the size of Mercury fits into a handful of fast passes and a few hundred photographs. We did not study Callisto and find it boring. We glanced at it, decided it was boring, and stopped looking. So why was it dismissed? 3 reasons, and all 3 felt convincing at the time. The first reason is the craters. Callisto has the oldest, most heavily cratered surface in the entire solar system. Look at a photograph, and you see a world that is saturated, pockmarked from pole to pole, crater overlapping crater, going back roughly 4 billion years. There is no smooth lava, no fresh ice, almost nothing young. To the eye, it reads as a fossil, a dead rock that nothing has touched since the early days of the solar system. Compare that to its neighbours, and you can see why scientists looked elsewhere. Io's surface is so young, so constantly repaved by volcanoes, that you can watch it change between visits, fresh sulfur, new lava flows, plumes hundreds of kilometers high. Europa's surface is young too, a smooth shell of ice barely scratched by craters, crisscrossed instead by long reddish fractures that hint at an ocean refreshing it from below. Both of those moons are doing something. They wear their activity on the outside. Callisto wears 4 billion years of standing perfectly still. The second reason is distance. Callisto orbits Jupiter at about 1,883,000 kilometers, around 26 times the radius of the planet itself. It is the outermost of the 4 big moons by a wide margin. Out there, far from Jupiter's churning interior, far from the tidal forces that torture the inner moons, it seemed like there was simply no engine to make anything interesting happen. And the third reason is that Europa stole the spotlight. Europa is closer, brighter, smoother, and visibly cracked, as if something underneath is straining to get out. Europa looks alive. Europa looks like a place where things happen. Once the scientific community fell in love with Europa's hidden ocean in the 1990s, the budget, the missions, and the imagination all followed. Europa Clipper alone cost over $5 billion. Callisto, the quiet one at the edge, got the leftovers. 3 reasons: it looks dead, it sits too far out, and its glamorous neighbour took all the attention. Every one of those reasons was about to be turned on its head. In December of 1995, a NASA spacecraft named Galileo, after the man who found these moons, slipped into orbit around Jupiter. For 8 years it looped through the system, swinging past each of the 4 moons again and again, and what it found at Callisto quietly demolished the idea that the moon was dead. The key instrument was a magnetometer. As Callisto moved through Jupiter's powerful magnetic field, Galileo measured how Callisto's own magnetic environment responded, and it responded in a very specific, very telling way. The field around Callisto fluctuated exactly as you would expect if there were a layer of electrically conducting material inside the moon, a layer that Jupiter's changing field was inducing currents in. On Earth, the thing that conducts electricity like that, buried inside a cold, icy world, is salt water, a global ocean. The logic is worth slowing down on, because it is the same detective work that built the case for every hidden ocean in the outer solar system. Jupiter's magnetic field is not steady from Callisto's point of view. Because Jupiter's magnetic axis is tilted and the planet spins fast, the field sweeping over Callisto rises and falls in strength roughly every 10 hours. A changing magnetic field passing through a conductor creates electric currents. That is the basic principle behind every electric generator on Earth. Those currents, in turn, create their own small magnetic field, one that pushes back. Galileo measured exactly that pushback at Callisto. Something inside the moon was generating currents in response to Jupiter. Solid rock and solid ice do not do that. A buried layer of salty liquid water does it perfectly. That is the same signature, the same induced magnetic field fingerprint that made the case for an ocean inside Europa and inside Ganymede. And here it was at Callisto, the moon everyone had written off as a frozen fossil. NASA's own estimate placed that possible ocean around 250 kilometers beneath the surface. Later analysis muddied the picture, suggesting the ocean might be deeper or harder to confirm than first hoped. But the core findings stood. The dead moon was not so dead. Under all those craters, under a shell of ancient ice, there may be liquid water, and there may have been for billions of years. Think about what that means. 3 of Jupiter's 4 big moons are now suspected of hiding oceans: Europa, Ganymede, and Callisto. We talk endlessly about the first 2. The third one, with its own buried sea, we somehow forgot to talk about at all. And if there is an ocean, the question that follows is unavoidable. Could anything live in it? On Earth, wherever we find liquid water, we find life in boiling vents at the bottom of the sea, in acid, in ice, in the dark with no sunlight at all. The deepest ecosystems on our own planet run not on sunlight, but on chemistry, on energy seeping up from the rock below. An ocean trapped under hundreds of kilometers of Callisto's ice, in contact with rock, kept liquid for billions of years, is not a guarantee of life, but it is exactly the kind of place we have learned not to rule out. The difference is that on Europa, even if life is there, the radiation makes it brutally hard to go and look. On Callisto, we could. Now we come back to the number from the very beginning, 540. Jupiter is not just a big planet, it is a particle accelerator. Its magnetic field is the largest structure in the solar system after the Sun's own reach, a vast invisible cage tens of millions of kilometers across. Trapped inside that cage are belts of high-energy particles, electrons and ions whipped to enormous speeds, slamming into anything that orbits too close. Jupiter's radiation environment is, by a wide margin, the most hostile place in the solar system that a spacecraft can go. How hostile? The spacecraft we send there have to be built like armoured vehicles. NASA's Europa Clipper, the $5 billion mission launched to study Europa up close, carries its most sensitive electronics inside a vault, a box with walls of aluminium nearly a centimetre thick, built for the sole purpose of keeping Jupiter's radiation from frying the brain of the spacecraft. And even with that armour, Clipper does not orbit Europa. It cannot survive there long term. It loops around Jupiter on a wide path and dips in for brief flybys, ducking in and out of the danger zone because staying would destroy it. That is what we build for our machines. Now imagine sending something soft and warm and alive, and the moons are not all in the same place inside it. Europa orbits deep inside the worst of those belts. The radiation raining down on Europa's surface is around 5.4 sieverts per day, 540 rem. To put that in human terms, a dose of around 600 rem, received all at once, kills about half the people exposed to it. Europa delivers that in roughly a day. NASA has stated plainly that an unshielded astronaut on Europa's surface would receive a fatal dose in a very short time. The ocean we dream about is sealed behind a wall of radiation that would kill you before you could drill into it. Now move outward. The intensity of Jupiter's radiation belts drops steeply with distance. Io, the innermost, is by some estimates bombarded with thousands of rem per day. An utterly lethal place. Europa, 540. Ganymede, far less, in the single digits by common estimates. And Callisto, sitting way out at 26 Jupiter radii, beyond the densest part of the belts entirely, receives only a tiny fraction of what falls on Europa. That is the contrast that should have made Callisto famous. 2 moons of almost the same nature, icy, ancient, possibly hiding oceans, orbiting the same planet. One of them is a radiation death trap, the other one you could walk on. The very thing that made Callisto look boring, being far out, being quiet, being away from all the action, is the thing that makes it survivable. Distance is not dullness, distance is shelter, and distance gives you something else too, a view. From the surface of Callisto, Jupiter would hang in the sky as a banded disk, large and serene, but far smaller and far calmer than the monstrous sky-filling Jupiter you would see from Europa or Io. You would be a spectator at the most violent planet in the solar system, watching from the cheap seats, far enough back to be safe, close enough to study everything, far enough to live. This did not escape NASA. In fact, NASA worked out the implications more than 20 years ago, in a study almost nobody has heard of. It was called HOPE, Human Outer Planets Exploration. Around 2003, NASA engineers asked a simple, audacious question. If we were ever going to send human beings, not robots, but living crews, all the way out to the Jupiter system, where would we actually land them? They could have chosen Europa. It is the headline moon, the ocean world, the place we most want to explore. But they did not choose Europa. They could not. The radiation made a crude landing there a death sentence. They chose Callisto. The HOPE study laid out a concept mission. A crew of 6 travelling to the Jovian system, with at least 3 astronauts descending to the surface of Callisto and staying for 30 days. A reusable lander, a surface habitat, a maximum mission length of around 5 years for the full round trip. Callisto was selected for one overriding reason. It sits mostly outside Jupiter's lethal radiation belts, making it the only Galilean moon where a human crew could land, work, and have a realistic chance of coming home. And the engineers thought it through in remarkable detail. The plan imagined Callisto not just as a place to plant a flag, but as a base, a forward outpost in the outer solar system. Astronauts on the surface could control robots and submersibles on the more dangerous moons by remote, sitting safely on Callisto while machines did the dying on Europa. They could extract water ice from the surface to make the rocket propellant, splitting it into hydrogen and oxygen, turning the moon itself into a fuel depot for the journey home. Callisto, in this vision, was not the destination so much as the harbour, the one safe place from which to explore everything else around Jupiter. A staging post at the edge of the known. Let that settle. The first serious NASA blueprint for humans in the Jupiter system did not point at the famous moon. It pointed at the forgotten one. A follow-on study even sketched a nuclear electric vehicle that could make the round trip and put boots on Callisto somewhere around the middle of this century. And then it was shelved. The budgets went elsewhere, to Mars, to the moon, to Europa's robotic missions. The plan to actually stand on Callisto was quietly filed away. But it was never disproven. The case for Callisto as humanity's first real foothold in the outer solar system is still sitting there in a NASA report, waiting. Here is the question almost every documentary skips. Why is Callisto so different from its 3 siblings? Why is it the calm one, the cratered one, the one that froze early while Io erupts and Europa cracks and Ganymede generates a magnetic field? The answer is one of the most elegant pieces of orbital physics in the solar system, and it explains everything. The 3 inner Galilean moons, Io, Europa and Ganymede, are locked together in something called the Laplace resonance. Their orbits are tied in a precise rhythm. For every 4 times Io goes around Jupiter, Europa goes around twice, and Ganymede once. 4, 2, 1. Because their orbits are synchronized like this, they tug on each other in a regular repeating way, and that constant gravitational tugging keeps their orbits slightly stretched. A stretched orbit means each moon is squeezed and released by Jupiter's gravity on every loop, flexed like a ball of putty worked in a hand. That flexing generates heat, enormous heat. That tidal heating is the engine. It is why Io is a world of volcanoes. It is why Europa keeps a liquid ocean against the cold of deep space. It is why Ganymede churns inside. The numbers are staggering. Io alone radiates more internal heat than it should be physically capable of producing, all of it generated by being squeezed and stretched by tens of meters on every single orbit. The entire solid surface of the moon rising and falling like a tide. Europa's ocean stays liquid not because the sun warms it. Out there, the sunlight is roughly 25 times weaker than on Earth, but because this same flexing keeps it warm from within. Tidal heating is the secret fire of the outer solar system. It is how you keep liquid water billions of kilometers from the nearest source of warmth. Callisto is not in the resonance. It orbits alone, outside that locked rhythm, beyond the reach of the chain. Without those regular gravitational tugs, its orbit stays nearly circular. Without a stretched orbit, there is no flexing. Without flexing, there is almost no tidal heat. And so Callisto, alone among the 4, was never given the internal engine the others got. The consequences run all the way to its core. Because Callisto stayed cold, it never fully melted and sorted itself out the way an active world does. Most planet-sized bodies separate by density. Heavy rock and metal sink to form a core, lighter ice, and water float to the top. Callisto only partly did this. Inside, it remains a strange, incompletely separated blend of rock and ice, roughly half and half, all the way down. It is, in a sense, a fossil of how these worlds began. frozen mid-assembly, never finished. This is one of the genuinely strange facts about Callisto, and one almost every retelling leaves out. Ganymede, its near twin in size, fully separated into layers, a metal core, a rock mantle, an icy shell, an ocean. Callisto, almost the same size, made of almost the same ingredients, did not. The difference between a world that became a layered, organized body and a world that stayed a frozen slush of rock and ice all the way down comes almost entirely from one thing: whether it was caught in that orbital resonance and given heat. Ganymede was, Callisto was not. Two siblings, born together, one given an engine and one left cold, and 4 billion years later, the cold one is the one we could live on. So when people call Callisto dead, they are half right and completely wrong at the same time. It is geologically quiet, yes, but quiet is not the same as simple, and quiet is not the same as worthless. A quiet world is a stable world. A stable world with water and low radiation is exactly the kind of place you would want to build something that has to last. And Callisto is not featureless either. It carries one of the most spectacular scars in the solar system. It is called Valhalla. It is an enormous multi-ring impact basin, the frozen splash of a colossal collision billions of years ago. At its centre is a bright region a few hundred kilometres across, and rippling outward from it are concentric rings, like the rings that spread when a stone hits a pond, except these are frozen into the crust. From the outermost ring to the far side, Valhalla spans something like 3,800 kilometres. That is one of the largest impact structures known anywhere, a single feature wider than the distance across the continental United States stamped onto a moon the size of Mercury. Valhalla is more than a pretty scar. Because Callisto's surface has barely changed in 4 billion years, that crater and the millions of smaller ones around it are a preserved record. Callisto is a logbook of everything that has crashed through the outer solar system since the beginning. The active moons erase their own histories. Callisto kept the receipts. And there is one more surprise. The moon, everyone called airless, is not quite airless. The Galileo spacecraft detected an extraordinarily thin atmosphere around Callisto, a delicate exosphere of carbon dioxide and later traces of oxygen. It is unimaginably faint, nothing you could breathe, nothing you could feel, but it is there, a frozen, forgotten, supposedly dead moon exhaling, slowly, almost imperceptibly into space. Where does the breath come from? The leading idea is that sunlight and charged particles are slowly knocking molecules loose from the ice on the surface. Carbon dioxide and oxygen, frozen into the crust for billions of years, freed a few atoms at a time and held in a wisp of atmosphere so thin it borders on nothing. It would not register on any instrument you could hold in your hand, but it tells us the surface is not entirely inert. Something is still happening there, at the level of single molecules, a quiet chemistry running in the dark at the edge of the Jupiter system. For decades, all of this sat in old data and shelved reports. That is finally changing, and not because of NASA. In April of 2023, the European Space Agency launched a spacecraft called JUICE. The name stands for Jupiter Icy Moons Explorer, and it is the most ambitious mission ever sent to study the worlds around Jupiter. It is on its way right now, threading a long looping path through the inner solar system to build up speed, and it will arrive at Jupiter in July of 2031. Here is the part that matters for our story. JUICE will not just glance at Callisto. Over its tour of the Jupiter system, the spacecraft is planned to make around 21 close flybys of Callisto, more than of any other moon. 21 passes over the world we ignored for 400 years. It will map the surface, sound the interior with radar, and measure the moon's gravity field precisely enough to test at last whether that buried ocean is really there. JUICE will spend the early part of its mission using Callisto as both a science target and a gravitational stepping stone, before finally settling into orbit around Ganymede at the end of 2034. It will become the first spacecraft in history to orbit a moon other than our own, but on the way, it will give Callisto the close, patient attention it has been denied since Galileo's day. There is a reason JUICE leans so heavily on Callisto, and it doubles as a perfect metaphor. Callisto, sitting at the outer edge of the 4 moons, makes an ideal gravitational brake and accelerator. Each time the spacecraft swings past it, Callisto's gravity reshapes the orbit, raising it, lowering it, tilting it, letting juice rearrange its path through the whole system without burning precious fuel. The moon we ignored for 4 centuries turns out to be the lever that makes the entire mission possible. To reach the famous moons, the spacecraft has to keep returning to the forgotten one, and on every one of those passes, JUICE will be looking down with instruments Galileo never had. Ice-penetrating radar designed to see through kilometers of frozen crust, a laser altimeter to measure the surface to within meters, spectrometers to read the chemistry of the ice. By the time it is done, we will know more about Callisto than we have learned in the 400 years since Galileo first saw it move. For the first time, we're going back to the forgotten moon on purpose, not as an afterthought, as a destination. So let us put the whole picture together, because it is not the picture we were handed. We were told Callisto was the dull one. In reality, it is nearly the size of a planet. It very likely holds an ocean. It preserves a 4 billion year record of the outer solar system, and it is the single most survivable surface in the entire Jupiter system. We were told its distance from Jupiter made it boring. In reality, that distance is the only thing standing between a future astronaut and a lethal dose of radiation. We were told its lack of activity made it dead. In reality, that stillness is what makes it safe. And it was that stillness, that quiet, that made NASA's own engineers circle it on the map when they imagined the first humans in the outer solar system. There is a pattern here that goes beyond one moon. We are drawn to the dramatic, the bright, the cracked, the violent, the Europas of the world. We build our missions and our stories around the places that look like they're doing something. And sometimes, sitting right next to the dangerous, glamorous answer is a quieter one we never bothered to study. Not because it was wrong, because it did not put on a show. Callisto did not put on a show. It just sat there, 4 billion years old, holding water, holding a record of everything, asking nothing, while we built billion-dollar missions to the moon next door that would kill us on arrival. The science fiction writer Arthur C. Clarke understood this before the data did. In his novel about the worlds of Jupiter, it was Callisto, among others in the outer system, that he imagined as a place humans might one day reach and inhabit. He saw, decades early, what the radiation maps would later confirm, that the path to the Jupiter system runs through its quietest world. When JUICE finishes its flybys, we will know far more than we do tonight. We will know whether that ocean 250 kilometers down is real. We will know the moon's interior, its history, its chemistry, in detail no telescope could ever reach. And the 400-year-old habit of mentioning Callisto last, almost as an apology, may finally come to an end. You, watching this, may well be alive when a human face looks down through a porthole at Valhalla's frozen rings. Standing on the moon, we spent 4 centuries calling boring, on the one safe shore in the most dangerous system in the solar system. The moon we overlooked may be the moon we live on first. It was never the dull one. It was the patient one. It was simply waiting for us to look. If you would like to keep exploring the real science behind the worlds we're only beginning to understand, consider subscribing. There is far more out there worth a closer look.